Hello! Today we're going to be doing decimal to binary conversion. I already did a video on octal, so it makes sense to do binary. We're going to do the number 196, and this is in decimal, so 196. First thing I'm going to show you is the binary positional values. From right to left, this increases by powers of 2. Alright, but don't worry about that right now. We're going to use it later. First step, 196 divided by, what do you think? 2. And if you knew that, congratulations, and if you didn't, life is over. I'm sorry. Anyway, 196 divided by 2 is 98, remainder 0. We can prove this by 2 times 98, which equals 196. 196 minus 196 is 0. Cool? Cool. Now, this next step, you take that remainder, you're going to nicely put it right with your binary. Okay? We're going to use that later. You'll take the 98, which was the other part of your answer, and you're going to shift it to the left. Now you just do everything again. 98 divided by 2, 49, remainder 0. 2 times 49 equals 98. 98 minus 98 would be what? 0, right? Very simple math. We're going to put the equation back together so you can see it again. And what we're going to do is take the 0. We're going to position it next to the binary. We're going to take the other part of our answer, that 49, and we're going to shift it to the left. Do it again. 49 divided by 2 is 24, remainder 1. 2 times 24 is 48. 49 minus 48 is equal to 1. See? And you just keep doing that over and over again. What did we do last time? We took our remainder. The remainder will then go from this place all the way over to the binary again. Then we're going to do this faster. 24 divided by 2 is 12, remainder 0. Nice. 0 goes up to the binary. And then 24 leaves, the other part of our answer is 12, shift it to the left. 12 divided by 2 is 6, remainder 0. Once again, 0 goes up there, 12 goes away, 6 shifts to the left. 6 divided by 2 is equal to 3, remainder 0. Again, 0 goes to the binary, 3 shifts to the left while 6 leaves. 3 divided by 2, 1, remainder 1. Go over, put it next to your binary, 1 shifts to the left, 1 divided by 2 is 0, remainder 1. Take the 1, put it up there, and if you look closely, we're at 0, which means we're done. Final step is take all those numbers that you put and make sure they're in the exact same order that you put them. And when you have them there, all you have to do is reverse them. So you put the original order down in front of you, and then you reverse it. And that is your answer. You are done. And the reason I have the binary positional values is now we can prove it. So what you'll do is take all of your answers and you'll multiply them by their corresponding column. And what does that mean? It just means you're taking your binary positional values and you're lining them up with your answer filled with zeros and ones, right? And you're doing it from right to left, okay? What I mean by that is the furthest right number in your answer, in our case it's a 0, it must be multiplied by the furthest right number in the binary positional values, which was 1. All right? So if you received a number that was only 0010, it means you'd only be multiplying it by 1, 2, 4, and 8, right? There are only 4 numbers, there's only 4 places. Right now, conveniently, we have 8 places and 8 numbers, so it works out. If you multiply all of these together, you'll receive 128, 64, 0, 0, 0, 4, 0, and 0. And then, if you add them all together, do you know what you get? You get the decimal value, which means, congratulations, you have figured out how to convert decimal to binary. And yeah, congratulations. And I want you to also remember, since it is powers of 2, technically, if you had a number like 400, you would just shift left one more time and multiply it by 2. 128 times 2, 256, right? The amount of numbers you get in your answer is the amount of times you need to shift to the left. Thank you, and good night.